Okay, here are some examples from exercise 504. Firstly, we're asked to sketch a point given that f of 2 equals 3, the first derivative at 2 is positive, and the second derivative at 2 is negative. So what we know is, we know f of 2 equals 3. So when x is 2, y is 3. It's going to go through that point there. Now we only have to sketch around this area here. We don't need to sketch the rest of the function because we don't know anything about it. We do know the first derivative is positive, so it's increasing. It's got a positive gradient. We also know the second derivative is negative, so it's concave down. So it's like it's part of a sad parabola. Now, if you split this parabola into two, on this side it's decreasing, so we don't want that. We want it to look kind of like this. So just around that point we need concave down, but it's a positive gradient. Okay, let's look at this second example. So this curve below shows the number of people playing Pokemon Go over 2019. So at the start of 2019, it's right up here. The number of people playing is decreasing over time. The curve is concave up. It's like it's part of a happy parabola. So are the first and second derivatives positive or negative? The first derivative, because the curve is decreasing, it's got a negative gradient, that'll be less than 0, negative. The second derivative, it's concave up like a happy parabola. Happy parabola has a second derivative greater than 0. So that is positive for concave up. How's the number of players changing over time? The number of players is decreasing, going down. Is the rate of change, meaning the derivative, increasing or decreasing? So one of the easiest ways to work that out, first of all, we know it's concave up, so the answer is increasing. Okay, another way is to actually write on the curve some gradients. So that might be -6, this might be -0.5. Those numbers are increasing. So it is an increasing. So therefore the curve is decreasing at an increasing rate.